by making a strong statement about science says we should do X, when in fact we could do X, Y, Z based on those exact same facts, then you're advocating for X because you're not discussing Y and Z, which, depending on what your values are, could be equally legitimate.
Welcome to the Case for Conservation podcast, where we explore biodiversity conservation and the environment more broadly and interrogate conventional wisdom for the sake of a more robust case for conservation. I'm your host, Andre Marder. Conservation and sustainability scientists are often expected to advise policymakers and other decision makers. But some of the issues that they're expected to advise on have broader consensus than others. So when is it appropriate to advise? When is it appropriate to advocate? And when should they simply present all the options or interpretations and leave it to the decision makers? Françoise Cardou is a plant and community ecologist and postdoctoral fellow at Carlton University in Ottawa, interested in understanding how people and nature affect each other in socio-ecological systems. In a recent paper in Biological Conservation, she and her colleague Mark Vellend discuss how important it is for conservation scientists to know which role is appropriate, to avoid being so-called stealth advocates. I began by asking Françoise to clarify a foundational distinction that they make in the paper between two main sorts of questions or problems, those that can be answered with more information and those that cannot.
The paper is really about the roles that scientists can play at the interface between science and policy. And there's been a lot of arguments in ecology and conservation science, whether scientists should be activists or should scientists be more hands-off and sort of neutral. Both of those alternatives really suppose that it's all down to the scientists to make the call as to what their role is going to be. And a development that's come out of that debate, partly in ecology, but also in science policy sort of expert circles, is the realization that it's not just down to personal choice, it's also a question of the policy context. So you called it a question, and what sorts of questions can we hope to address with more or less information? I wouldn't necessarily call them questions. I would call them maybe management challenges, because for scientists, when we think about questions, we're thinking about scientific questions, whereas these are really what we're talking about are management challenges or management issues. And so folks like Roger Pielke, whose work I'm citing extensively, this is not our framework. This is really Roger Pielke's honest broker framework that we're bringing to conservation biology and ecology.
So he's from outside the field, is he? I know the name from the paper, but not from elsewhere. Is he a conservation biologist?
No, not at all. He's a science policy person. That is his expertise, is the interface between science and policy. I believe he was involved in climate science for a long time, with being a co-author in the IPCC, and now he's also looking at sports policy.
Okay.
So I think his interest is really science and policy per se. What we did in the paper is really just take his framework and kind of put it in front of ecologists and conservation biologists to just say, like, look at how neatly this maps onto so many of the problems and the situations that we grapple with all the time. And so I think one of Pielke's contributions was really to draw attention to the importance of the policy context in shaping the role that scientists can play at that interface with policy. And I think the best way to explain the importance of this context is to draw a comparison between two situations. So first situation, let's say you have a bunch of people in a room, someone looks out the window and they see a tornado, which seems to be heading for that building. So you have a community inside the building, you have a choice. You can head to the basement and hopefully stay safe there. That's still pretty risky if the tornado hits that building directly. And so the alternative choice is to leave the building for safer premises, but you're taking a risk kind of leaving the safety of that building. Now, that decision is going to depend mainly on what you know and what you don't know about the trajectory and the strength of that tornado. And so one thing that would be really helpful in that situation is more information about the tornado. And so you could really imagine calling up an expert or calling up the weather service and being like, what should we do here? Do we need to move, or can we just head to the basement? And so one key feature of that situation is that there's general broad agreement about what the goal is here. Everybody in that building is just trying to preserve lives to make sure nobody gets hurt. And so that makes it fairly easy to then reach for more information and proceed from there. And so we can call that tornado politics, if you will. Imagine a second situation where you have the same bunch of people in a building. There's not a tornado outside. Instead, these people are trying to decide whether they should allow non-essential abortions in their community. And so here, different people are going to have really different views on that issue. It's going to be informed by faith, ethics, the whole range of things, personal experiences. And so some might prioritize the potential life of the fetus. Others are going to put more emphasis on the life and freedom of the pregnant person. Some facts might enter that conversation. They could include things like, statistics on individual outcomes following unwanted pregnancies, or evidence on when fetuses develop this or that bodily function. But there's very little chance that these facts about personal outcomes or about, the nervous system and when it develops exactly, there's very little chance that those facts are going to have any impact on any individual's personal positions. Those positions are based on something that runs a lot deeper. And so in a situation like this, facts don't really help. And more to the point, focusing on facts can actually distract from the core issue. And so suddenly we find ourselves in a fact war, arguing about exactly what time does a nervous system develop in a fetus, or which sensation matters, or which function matters to define, personhood, when in fact, that's not where the disagreement is. The disagreement is over what the goal is for that policy. And so here we have what I would call, or Roger Pielke calls, abortion politics. And so those two examples, the tornado example and the abortion example, really give you a sense of, on one hand, situations where you have a value consensus, and so you have shared goals where you can reach for additional information and that can help you move forward, versus situations where there is value conflict and the same set of facts can really lead to multiple alternatives depending on whose value you prioritize. And so that's the big difference between these two types of contexts. And if you think about it, in conservation and environmental management, we have quite a few examples of tornado politics where we do have value consensus, but we probably have a lot more abortion politics. So on the tornado side, where more information is really helpful, one thing that pops to my mind as someone living in the North American Northeast would have been acid rain. Acid rain was immediately or pretty rapidly recognized as a problem. Nobody wanted to see the environmental effects that we were seeing throughout the region. And so pretty quickly, scientists got to work and they were able to pinpoint what the source was for the acidity, and things were able to be implemented. Now, on the other hand, I think most people that are involved in conservation are going to be able to think pretty easily about situations where there's not a value consensus, so that fit more under the umbrella of abortion politics. So, for instance, the reintroduction of large predators, whether it's bear or wolves in Europe, for instance, there's always a lot of debate around that. Or you can also think about the lethal control of invasive species, particularly when those invasive species are charismatic. They might be cats, for instance, and that always creates quite a bit of debate because people have very strong values, strong and divergent values on those management policies.
It's really interesting what you sort of touched on it now, but I think you also mentioned it in the paper, this fact that very often in the latter example, the abortion politics examples, it's very often the case that the more information that's available, the more people dig into their positions, right? So it's kind of
Mhm.
counterintuitive that you think that I think very often the mistake that we make in conservation biology is that the more information we give people, the more likely we are to be able to convince them. But that doesn't fit into that abortion politics model, right? It often works exactly the opposite direction.
It works in fairly counterintuitive ways, at least counterintuitive for folks, who are swimming in the realm of science and building an edifice on past knowledge towards the future. So I think for us scientists, this is especially difficult to understand. But when you think about it, what we are at our base are strategic political animals, and we're very good at making our point. And so in a political situations, we're going to tend to reach for all the tools that are available to us to make and support the position that fundamentally we prefer on very basic ethical grounds. There have been some results, for instance, in climate change science, where they showed that more science literacy did not lead to being more amenable to evidence regarding climate change. People on both ends of the spectrum were just more polarized than comparable samples of people with less science literacy. And that's because when you have more science literacy, what you are is more adept at utilizing the facts that are out there, which are diverse, and assembling them in a way that supports your pre-existing position. And so people are just being strategic, and they're more or less good at it.
Right. In your paper, there's a single, very simple diagram, which I assume is taken from Pilkey's work, or is that your adaptation of that, more or less?
It's very slightly tweaked for narrative purposes, but
Okay.
essentially it's the same.
Okay. And that diagram talks about four different roles that scientists can play in real-world environmental policy and management. And this is kind of I would say correct me if I'm wrong, but this is more or less the center of your paper, the core of your paper.
Mhm.
I think it would be a good time now to describe each of those roles, to explain what they are and also the different questions that lead to each of them. So could you kind of sketch that? And then along the way, perhaps I can sort of stop you after you describe each of them and get a little bit more clarity if necessary.
So I think that the first and students and undergraduates and graduate students are going to be familiar with this, but the first question that scientists kind of, once they've chosen their field, have to ask themselves is whether or not they want to engage directly with policy. It's important for me to highlight that there are tremendous contributions to be made that have real and very important real world impact that doesn't require scientists to do anything other than their usual work. Go to your department, find what the knowledge gap is, address it, do the experiment, publish your work. And that work contributes to a body of knowledge into which other scientists and policymakers are free to tap. And so it's important to underscore that so-called pure scientists are not, they're not generating knowledge that has direct impact. They're just contributing to a general body of knowledge, and they're interacting with policy, but in an indirect way. So in ecology, we only have to think about the theory of island biogeography. It was mainly a theoretical advance, but it's ended up having an incredible impact on conservation strategies worldwide, when really they were just trying to figure out how these islands worked. And so you never know what might become critical in the future. And so this first branch is really whether or not you just want to contribute to the general body of knowledge, or if you want to address very specific needs and interact with policymakers.
So that's what you call pure scientist, right? That first category.
Mm-hmm.
I know it's a bit of a divergence, but would you mind just very briefly explaining what island biogeography is? The conservation biologist listeners will know, but just for those who are not within that realm, because it is a really interesting subdiscipline.
So island biogeography is a theory that was developed in the 60s by Wilson and MacArthur, and I hope I'm getting all of this right, but which basically tries to predict the number of species that you might find on islands in an archipelago based on very simple parameters. So looking just at the area of each island and at its distance from the continent. And they were able to get some pretty good results with that. But as it happens, an archipelago of small islands in the ocean actually looks a lot like islands of forest among a matrix of agricultural land, or it could be different mountaintops across a landscape of lowlands. And so this conceptualization of how groups of habitat patches work in a landscape when they're interrupted by an inhospitable matrix is really kind of directly transferable to many questions that we have in conservation. And so there's been a lot of work and a lot of debates as to exactly which insights should be gleaned from that hypothesis to apply it to the development of marine protected areas and national parks. Should we plan for single large parks or many small parks, for instance, in an island sense? And so it's been a very sort of influential theoretical advance that has had quite a few real world impacts.
Right. But as you say, the kind of motivation for it in the first place was purely ecological. It was a pure science. It's an example of pure science, right? Because there was no kind of, at least originally, no intention of influencing policy with it.
I mean, I hope I'm getting that right. I don't want to. So one thing that I want to do, and we tried to do this is probably going to come up. Is it's quite hard. I don't want to assume anything about people's motives. No, we can only judge people by what they do. The original contribution was very theoretical, and the original authors may or may not have sort of had a glimpse of the potential impacts of their theory, but certainly the initial paper was a theoretical contribution.
Perhaps almost anything that we do in conservation biology, even if it's originally intended to be pure science and separate from policy, can and usually does end up affecting it in some way. So that kind of raises the question: is there really any such thing as pure science in conservation biology?
So your statement is partly right in that I do think that conservation biologists, because they have conservation in that title, always have a goal of being directly applicable. I think that's part and parcel of that discipline, is to advance a specific agenda which was outlined by Soule. I think if you look a bit more broadly at ecology, I think sure, there's purely theoretical ecology out there. I think in ecology, maybe more so than other sciences, there's a certain pressure to end every scientific paper with a little paragraph about what the potential applications are. But even in those cases, I would argue that the main contribution and motivation for many papers is purely, we want to know.
Right. Okay, so that's pure scientist, the first branch of the diagrams tree. So and then there's a second question, right?
Yeah. So let's say that you've decided that you want to engage directly with policy. Now, the second step is really to look around and assess whether the policy context that you're interested in, are you walking into a situation that's more like tornado politics or more like abortion politics? So are you walking into a situation where there's broad value consensus, we all have the same goals, or in a situation where there's still a lot of debate and different actors, different stakeholders in a given community, for instance, will have different, ideas about what should be done. Other fields, we can think of medicine. They have it pretty easy. Here, they take a hard left because they have a stated purpose, which is to save and preserve human life and cure illness. I don't know the Hippocratic Oath by heart, but that's the purpose. That's stated. So there's just an agreement that that's what the goal is. And so from that point forward, it makes it pretty easy to link science with advancing those goals. Outside of that, it can be pretty difficult to gauge exactly what the consensus is, especially as scientists in university departments. We're often surrounded with people who share our interests, our passions, and And so we often get the impression that, there might be more consensus around a given issue than there really is. And so one way to assess this for, when you're not a doctor and you're just an ecologist trying to figure out which side of that question that you fall on, one way to assess it is to see whether there's an official policy out there that exists and that was decided via a legitimate process, like through a democratic government, or through a consultation process or some other version of that. Then you can act as a science advisor. And that's the second role that we outline in the paper. And so you can make statements about what we should or shouldn't do based on the science, because there's a given goal that's already stated and that was arrived at through a legitimate process. And so it's possible to make direct links between science and what we should do. One example that we give in the paper is the goal of sustainable forest management. Now, sustainable is a big word. I don't want to. I'm gonna take it on simple terms for now. But for instance, in many Canadian provinces, we generally agree that we're okay with commercial exploitation of forest as long as we continue to obtain ecosystem services and to be able to harvest trees from those same forests far into the future. So we'll only take as much as we can and no more, because we don't want to harm the ecosystem. And so given that goal, it is possible for scientists, and we have them that work in government right now, it is possible for scientists to come in and say, well, given this goal, here is about how much wood you should take out of the forest in any given year. And here's maybe a safety margin around that if you want to be more or less certain about what you're going to do. And so this is how you can link scientific insights, facts, basically, with specific environmental goals. There's a lot of issues that ecologists and conservation biologists might want to weigh in that are not yet legislated or that are legislated in a way that really gives maximum flexibility to governments on a case to assess things on a case by case basis. And usually that's a sign that there's not currently a value consensus around a given issue. And so let's say that you've decided you're not in tornado politics side, you're on the abortion politics side. And so that means that when you've reached that side, it means that the same set of facts can actually lead to totally legitimate policy alternatives that can all be justified depending on what the values are that you bring to the table. And so one thing that you can do as a scientist is you can pick one option and decide that this is the one that I prefer based on my values and my ethics. And you can make the case for that alternative. And in that case, what you're doing is you're being an issue advocate. I think that's the role that most people associate with conservation biologists. I've certainly sat at tables where, in my mind, I was coming in as a scientist, but in everybody else's mind, policymakers, government people, in their mind, I was the activist. I was there to push an agenda because I was coming from the ecology, the conservation side of things. And so they expected me to represent a specific set of values.
So that distinguishes you in their eyes in that situation from a science advisor, right? If they'd seen you as a science advisor, which was the second category you mentioned, that would mean that they were seeing you as someone who was just informing them about a goal that they were already heading towards, right? That's the key difference.
Mm-hmm. Absolutely. Versus the alternative, where I think many ecologists and conservation biologists, people expect us to argue for specific policy alternatives. So some examples would include scientists that really pick one issue and make that their thing. You could imagine people who really kind of take on the challenge of species at risk. There's been really effective issue advocacy for preserving landscape connectivity, for instance, or climate change action. And these are all areas where we can really think of individual scientists that have really driven the general discourse in society towards their preferred policy alternatives as they saw it. And so in your question, I think your initial question mentions stealth advocacy. And so I think this is the right moment to kind of point this particular pitfall. And so this happens when scientists make statements about what we should do, but the statements are phrased as though they were happening in a context of tornado politics. Science says we should do X, when in fact they might be actually operating in a context of abortion politics, where more facts are not really going to solve the issue, and different values can actually lead to multiple alternatives. And so what we should do is not only dependent on the facts, it's actually a lot driven quite heavily by the values of people that are part of that conversation. And so the result is that they make statements or argue in favor of very specific policies as though they were informed by facts. But in fact, that preference is really based implicitly on their own value judgment, which may not be shared by everybody in that conversation. And that's really independent of whether, as individual, those scientists arrived at those conclusions by looking at the facts. That's a personal journey that everybody goes on to decide what your preferred policy alternative might be. Some people might base it on, the latest journal article that they read, but some people are just going to base it on what they remember nature to look like when they were children. And those two methods of arriving at a preferred version of nature are equally valid.
Right. So stealth advocacy comes in where issue advocates come in, right? Stealth advocacy is sort of associated with issue advocacy.
So stealth advocacy happens when you take a wrong turn, as though you were a science advisor, when in fact you're on the abortion politics side of things. And there are multiple policy alternatives that can be legitimated by the same set of facts. And so by making a strong statement about science says we should do X, when in fact we could do X, Y, Z based on those exact same facts, then you're advocating for X, because you're not discussing Y and Z, which, depending on what your values are, could be equally legitimate.
Right, I get it. So basically, stealth advocacy is when an issue advocate is not being transparent about the fact that they are an issue advocate. They're kind of masquerading as almost like a science advisor on an issue by kind of pretending that this issue is resolved, whereas it's not a resolved issue.
Well, I think this is, I think the way that you phrased it implies intent. And I think stealth advocacy certainly could, happen in a strategic sense if an individual, a scientist, is intentionally trying to make their point. But I think in many cases, it just happens unintentionally for a range of reasons. But it could include, for instance, assuming that people agree on issues that they really don't agree on, because we happen to swim in a very specific pool of people where these things are completely uncontroversial. But if you step back just a little bit into broader society, many of these environmental concerns are actually quite controversial, or you might find some more pushback than you might think. So just by missing that part of the assessment, I think you can make strong statements about what we should do based on the facts, when in fact it's really a question of values, and what you're inserting there are your own specific values.
Right. So it's generally an inadvertent mistake, I suppose you could say. And perhaps this is probably not a binary thing, right? There's a bit of a continuum there. I think sometimes people are somewhat aware that they're being stealth advocates, but that they have sort of maybe a little nagging doubt, but not enough to make them change the course that they're on. In other cases, in rare cases, I guess they might be intentionally trying to mislead.
Mm-hmm. I think all of these possibilities, there are probably examples out there of that happening. I assume that people who might be doing this intentionally are unlikely to be reached by this paper's argument for not doing that. And so I guess the paper is really addressed at people who might be doing unintentionally, and who, if you lay out the argument that this may be, making things worse and making it harder to solve environmental challenges, I think that inadvertent stealth advocates would be absolutely willing to maybe tweak the way that they engage with policy, just to phrase things a little bit more transparently, so that the limit between what the science says and what their own values say might be a little clearer to the general public.
So there's another category, right? So we've had 3 categories so far. Can you tell us about the first one? That's honest broker, right?
And so first we took a turn and we decided that we wanted to engage directly with policy. And then we decided that we were in abortion politics territory, which means that there's, not really any value consensus or agreement, and the same set of facts can justify multiple policy alternatives. So scientists can choose to be issue advocates and advocate for either one or a subset of solutions, but they can also engage with the full breadth of policy alternatives that are out there. In order to do that, one thing that's very helpful is to approach it like a scientific problem and start mapping out what might be the trade-offs that exist between different policy alternatives, so that as a society, we can make informed decisions about which compromises we might be willing to make and which ones we might not. We can put numbers on those trade-offs so that we can discuss options with decision makers. Now, I think people see the honest broker sometimes as the panacea. Obviously that's the best role, but really it's quite difficult because you need to be prepared to engage earnestly with policy alternatives that you might actually disagree with on a personal level in pretty severe ways. But you're doing that because you believe that solving the problem, even if the solution takes some consensus and some give and take, is better than not solving it at all, or aiming for a perfect solution that may or may not come. And so I think the honest broker is a difficult role to take, and you need to be very open-minded and sort of attuned to the values of a wide diversity of people. But I think it's a role that has a lot to contribute to conservation and environmental management in general.
I think all of these roles, and maybe honest broker more than any of the others, I'm just kind of thinking about two ways of looking at it. One from the inside, so let's say from the view of a conservation biologist, and the other one would be one of those people sitting at the boardroom table that we were talking about earlier on. So from the outside, it might be quite difficult to tell whether someone's an issue advocate or an honest broker or a science advisor. It might be quite difficult to tell the difference, right? But I guess that you're appealing to the conservation biologists themselves to identify who they are.
Mm-hmm. And I think that can be done in an unobtrusive way. I think this is something that we can fold into our practice. Other papers out there have argued that, ecologist or conservation biologist should be one thing or should all be another thing. And one thing that we do not do in this paper is advocate for one role over the other. I think that all of those roles have very important things to contribute to environmental management. And some roles are going to suit different personality types more than others. The only thing that we do argue is that these should be done transparently. And so for a science advisor, for instance, that might mean being knowledgeable about which specific policies your science is addressing and being able to cite that policy, be able to make a statement, given policy X, here is what we should do, or given, rule Y, here is what we should do. I think for issue advocates, I think they should start and state quite clearly the values that are going into their advocacy. I don't think it's going to detract from them because, and this is also insight that's come from climate change research, is that the general public actually responds well to narratives that are based on values rather than facts. And so I think it can also be a powerful tool to advance those issues that issue advocates are really passionate about. And then for honest brokers, I think they also need to recognize and they can lead any facilitation effort that they might make to discuss policy alternatives. I think they can lead that with statements about their own potential biases, because we all have them. I certainly have some. I work in cities and I have specific invasive species that I strongly dislike and based on personal experience. But I can also say that to managers when I meet them and I discuss what we're seeing happening in plant communities and cities. I can contextualize what I'm saying and tell them, what my background is so that they know how to interpret it.
Yeah, it's a lot about trust, isn't it? That invasive species example reminds me of a quite famous example in Cape Town, which is my home city where um, there are areas of what's naturally fynbos, that's the natural vegetation, which is very biodiverse, which have been replaced for maybe 50 or 100 years by pine plantations or pine trees. It's the remainder of plantations. And the biodiversity people, including the ones who work for the city, and this is going back 10 years, so I'm not sure how much things have changed, but they were advocating getting rid of the pine trees so that they could restore the surrounding, the fynbos to the surrounding fynbos. But the local community valued the pine trees as shade and picnic area and places to walk their dogs and that kind of thing. So it was a real clash, a real kind of cultural clash. And as I mentioned, that's an interesting one because and unfortunately, I'm not familiar with the policy, but there may have actually been local government policy supporting the biodiversity scientists. So they were kind of basing it on what they considered to be some kind of consensus. But that didn't change the fact that it clashed with with the public's values, you know?
So I'm familiar with that example, and I think that there are really strong conservation biologists working in South Africa who are being honest brokers about this. I'm thinking specifically about Luke Katgeiter, who's a colleague and who very kindly reread this paper to validate some of the statements that we were making about invasive species. I shout out to him if he ever hears this. But it is an open question whether, government policies are an accurate reflection of societal consensus, or sometimes they're not. We only have, if we step back from conservation biology, the US famously, the American population famously supports gun control, and yet it's unlikely or impossible that it will ever become a legislation for political reasons, because it's a loser for any politicians that takes that on. And so it's a real question whether using government policy as a yardstick for value consensus is appropriate. But I would argue
it's
that
perhaps the best that we can do, right?
Exactly. So I think that's my best answer, is that it's the best thing that we have right now, however imperfect it might be. And it's also what we use for many other things outside of conservation biology, where we use democratic processes to make hard decisions about justice and housing and planning in many realms, and we rely on those processes. So I don't see how whether conservation should really be different than those other things. And there's been so much talk about polarization, especially around science-based issues, so vaccines and nuclear energy, and there's quite a few examples out there of this polarized debates that gets whittled down to facts, and people then tend to argue about facts, when I think if they really laid it out on the table, they would find that the root of the disagreement is values. And then that feels like we could have a more productive conversation.
Next time, I'll be speaking with environmental scientist Earl Ellis, who's been very prominent in the long-running discussion about renaming our current epoch the Anthropocene. Just a few weeks ago, after more than a decade of debate and research, the Responsible Working Group voted against making the Anthropocene epoch official. Earl explains why this decision was reached, and also why it doesn't really change anything. This is a really fascinating chat, so please keep an eye out for it.